class, students taking additional mathematics. So I give them a test, and this is the marks that they get. 16 marks, no student. 17, no student. 18, no student. 19 marks, one student. 20, one student. 21, one. 22, 23, all one student. Then 24 marks, I have two students. 25, I have two students. 27, three students. 29, three students. 30, I have four students. 32, got five of them, got 32 marks. And so on, you see, and so on. Then here, 7, 7, 8, 8, 8, 8, 8, 8, 8, until 45 or so, 8 of them got 45 marks. As you go, the marks go higher and higher, we have fewer and fewer students. Finally, the highest mark, 65. I have only one student. Now, this type of distribution, let's say I don't know the average and the standard deviation. So I'm going to calculate the average and standard deviation. So how many students altogether? I have 198 students. And the mean, that means the average marks, 42. And the variance is using the formula for variance, sigma x squared over n minus sigma f x over sigma x over n holding square, something like that, right? So using the formula for variance, you calculate the variance, also calculate the standard deviation. Another thing I calculated is also the probability. Okay, one student, 19 marks, one student. So one out of 98 students, 198 students. So I calculate the probability. Then 42 marks, I have 8 students. So 8 divided by 198. So I also calculated the probability for a student getting 42 marks. Now you can see the trend there. The trend is there. Now the mean is 42. Where is the 42? This is my 42. This is my 42 here. Where is my 42? Yes, this is my 42 marks. Now, if you see, when you go higher and higher, we have less and less student from 42. And from 42, I go lower and lower the marks. Lower and lower also, I have less and less students. The most student is around 42. So when I plot the graph of the frequency against the marks, right? So the frequency against the marks are 42, around 42 there. This is around 42, right? This is around 42. You have the most number of students. As you go higher and higher the marks, the student become less and less. Or if you go lower and lower the marks, also we have less and less student. So this blue mark here shows the frequency. So this type of distribution you can see is like a bell shape. The center, the density a lot. As you go further and further away, the density become less and less. So there are less and less students as the marks go higher and higher, or as the marks go lower and lower, you have less and less students. Most of the students, they are concentrated around the mean, or the average. Any questions so far? Any question? No, no question. Then after plotting the frequency, the number of students against the marks, I also want to plot the probability. probability follow the number of students. So the probability definitely will be higher at the center here. Okay, I'm referring to this one here. Okay, so I'm referring to the graph here. So the probability distribution is also something like the frequency distribution. It is the probability is the highest at the center. As you go and further away from the center, the mean, the probability will be less and less. So if I say I want a student to have 70 marks, the probability is very, very small. Of course, the number of students here they show is 0. Theoretically, there will be zero point 0.1 student or 0.02 student. If the population is big enough, we will have students more than 70 marks. Because our population is very small, only 198 students. That's why we cannot show students that are very outstanding, right? But if our sample population gets bigger, then we can get this type of student. Okay, again, the probability of a student getting lower marks than 42 become less and less. And in fact, if you want 10 marks, no student get 10 marks. But of course, we have only 198 students. But if the students, we have 1,000, 2,000 students, probably we can get students with 10 marks or even 0 marks. We can get this type of student, right? Then the next thing you want to know is this probability distribution is what is the relationship with the mean and the standard deviation. Of course, the variance it has no physical meaning, but the standard deviation has meaning. Okay, now let's say our mean is 42. We are looking at this number here. The mean is 42, right? Now, the standard deviation is 9.5. So if I take 42 plus 9.5, 42 plus 9.5, it will be 51.51. So this line here is 51.51. And most of the student will be inside this range here, between 42 and 51.51. Now, if I use this 42 and minus the standard deviation, I will get 32.5. And this line is 32.5 here, right? Most of the student will also be inside this group here. So if I take the mean, I plus the standard deviation, 9.5, and I take the mean, I minus the standard deviation, which is 32.5. Most of the student will be between these two numbers from here until here. That is from 51.5 to 32.5. How many students are there? About 68% of them, they lie between plus standard deviation and minus standard deviation. Most of the students will be between these two values, between 51.5 and 32.5. And how many of them are there? 68% of them will be within this range. Any questions so far? Sherwin, any question? Jia Yan, any question? No question. This is just explaining only. If you understand, then understand. You cannot understand, then probably I explain again. That's all, right? Okay, right. No question. Right. Now, if you find that the probability distribution is like this, like the shape like this, right? Like a bell-shaped curve, then this is called a normal distribution. What is the characteristic of a normal distribution? The characteristic of normal distribution is that most of the data will concentrate around the mean. As you go further and further, the probability of getting these numbers, they will become less and less. Okay, so this is a probability called normal distribution. And it can be written like this. X is distributed normally with mean 42, standard deviation, sorry, not standard deviation, variance 91.1. So the two numbers that we have in a normal distribution is the mean and the variance. These are the two parameters that we have. For binomial distribution, if x is distributed binomially, the two parameters, they are n and p. N is number of attempt, number of trials, right? And P is the probability of success. That two parameter defines a binomial distribution, whereas the mean and the variance define a normal distribution, right? So in general, we say that X is distributed normally with mean and standard deviation. Sigma square is the standard deviation. Sorry, sigma square is the variance. So the second number is the variance. It's not the standard deviation. Okay, it's the sigma square. It's not sigma. And the probability of x between mu minus sigma and mu plus sigma is 0.6826. That means the probability of x between these two numbers, this probability here, the probability here between these two numbers, the probability is 0.6826. And if you translate them into percentage, how many percent of them will lie between positive sigma and negative sigma? 68.26%. Anything you want to ask?